Hello everyone, I am Sridaksha Jeevi and my friend Parvati will be explaining the thermal conductivity of copper. Okay, now let's go to the theory part of this experiment. Here we will be finding the thermal conductivity of the copper using the concept of electrical conductivity. Why? Because we know that pure metals, the conduction of heat is mainly due to the electrons, and movement of electrons is considered to be a current. So conductivity of electrical conductivity is being directly related to the electrical conductivity. Okay, so there is a relation called Weidmann-Franz relation. It states that K by sigma is equals to LT, where K is the thermal conductivity, sigma is electrical conductivity, T is absolute temperature, and L is Lorentz number. According to free electron band theory, L is known to be the universal constant. It is given by the relation pi square by 3 into K by E to the whole square. So we will look into the how the instrument is being built. Here we will be using the two thermocouples and they have been junctioned to a copper constant which is a copper tube of 19 centimeter, and I will be showing the image. Okay, here two copper constant thermocouples are made. Two junctions of each thermocouples, they are fixed with super glue on each side of the copper tube. The distance between the junctions are taken to be D1. The exact value of a D1 will be given on the instrument top, and we will be calling the two copper current leads as CL1 and CL2. They are soldered to copper tube at its two ends. Then between these two current leads, two more voltage leads VL1 and VL2 are soldered to copper tube. So the distance between this D2 and D1 will be the result for finding the voltage. In turn, we will be finding the thermal conductivity. So how they have molded the tube? The layer of cotton is wound on the copper tube. On this, the paper layer is wound. On that, aluminum foil. Again on that, one more paper, and then they have covered it. This is done to reduce the heat loss by convection and radiation. So here, if you see the instrument, this is a thermal and electrical conductivity of copper instrument. Here these are the CL1 and CL2 terminals, and these are the VL1 and VL2 terminals. These are thermocouple junctions TC1 and TC2, which we will be using to find the thermal conductivity. And these are for heat terminals. These are called as heat terminals. Mainly we will be using these two terminals.
Now we will move on to the experimental setup of the experiment. This is the thermal and electrical conductivity of copper box. This is the constant current source, and this is the DC differential amplifier, and we use the multimeter to record the voltage output. Now what we have done, we have taken the output of constant current source and given in the terminal of H1 and H2 to supply the current. After that, from the thermocouple 1 TC1 to terminal goes to I1 of the differential amplifier. Similarly, thermocouple 2 goes to the I2 of the differential amplifier. Since we use only two thermocouples, we have connected only I1 and I2, and I3 is left free. Now, to determine the output voltage that we get in the differential amplifier, we are connecting the output of the differential amplifier to the multimeter to determine the output voltage. What we have to do is, we have to on the experiment and set the current for 260 amperes. We on the circuit, and you can see, and before that we should make sure that the constant current source, both the terminals are in high mode. Now we have set the current to 260 amperes and we wait for 45 minutes to stabilize the apparatus. After 45 minutes, by the decrease of 20 amperes of current, we take the output voltage for each I1 and I2 terminals and note our reading. Now this is the procedure part. And you can see this is the preliminaries which we need: the outer diameter, distance, inner area, and the resistance. All these details are provided upon the box. Now moving to the tabular column, the current what we have reduced into 2020 milliamperes we have written here, and Q is the energy, and V1 is the reading which we take from the terminal I1 with the help of the multimeter, and V2. Delta T1, delta T2 are calculated using the formula 100 into V1 by 40. So using that we calculate delta T and we take the ratio of Q by delta T. After that we take the average of Q by delta T and we apply in the formula of thermal conductivity, which we have already seen in the theory, and we determine the thermal conductivity. Hence the experiment ends.